皆さん、はじめまして。島根情報処理センターの小倉です。
I am Ogura of Shimane Information Center. Good afternoon. It is my great pleasure that I may be able to give 15-minute talk at this conference. This is my brief introduction. I am from Unnan City of Shimane Prefecture. I live in Unnan City. After graduating from technical high school in the prefecture, I have worked for Shimane Information Processing Center. At the center, my activity is the development of IoT systems. That's all for my introduction. My computer program mruby/C, and I want to talk about the product called R-board. R-board, the origin of the R-board, microcomputer board for MicroPython is called PyBoard. Since it is the board for mruby/C, I thought RB board is good, but I don't like B to be doubled, and that's why I call it R-board. The objectives of R-board. There are 3 objectives. Ruby engineers uses mruby/C to develop IoT devices, so it is used as a first step. It is to allow children to experience programs of moving real objects with Ruby, and to offer people engaged in embedded programs on an option of MyRuby-C. These are the 3 objectives of our board. I want to create a mruby/C microcomputer board which is cheap, simple, and easy to handle. I want to talk about the flow of development using the mruby/C. How to write programs using the system. First, the development using C language. We selected microcomputer-specific IDE, and we write the program to the microcomputer, and it is to be embedded in the electronic circuit. This is the general flow. Then, taking an example of mruby-C, the development goes this way. We have mruby/C added to the previous slide. It seems as if we have an additional work to work. Why we may not be able to keep the C part? The reason is simple. Each microcomputer has different internal systems, so we have to have different compilers. So C development cannot be eliminated. And if we don't know, we have to study and develop compilers. If you have a knowledge, if there are people who have a knowledge on C development, we have to ask the person to do that. But mruby/C, we would like to use mruby/C only. How to implement mruby/C? I implemented mruby/C, which is called R-board. It becomes a microcomputer board, so we may be able to create a simple board. mruby/C IDE is used to write the program for mruby/C. We don't have to have any dedicated devices. We use micro USB cable to start programming. Sensors and actuators are used as a Grove sensor module. We don't have to make any soldering. We can just connect connectors and connectors with lines. We can handle a lot of connectors and sensors. And we can have compatibility to usual board, and ARNI can be used, or part of the system has been used. This board is compatible to mRuby/C 2.1. mRuby/C 3.0 is coming to the market, so we would like to make it compatible to 3.0. And we may be able to update the version after you purchase it. So this R board can cover mRuby/C 3.0. C should be written, so we need to have a dedicated writer for that. This connector, we use the writer to write the program with C. C and mRuby/C can be experienced while writing the program. Now I want to show you the demonstration using this system. This is the temperature data sending to the Google spreadsheet. Temperature sensor, this is a thermistor sensor, and this is a globe module, and connector to connector, the connector is connected to another connector with line. This is a Wi-Fi module we use. This is the program we use this time. The upper part is ADC, analog digital converter, and UART, Wi-Fi module serial communication instance. They are generated. URL variables is HGE. This is the Silicon Lab Wi-Fi module command for communication. The latter part is the Google Spreadsheet API. And while true part, ADC start to temp equals part, the temperature data is acquired here and calculated. And we put the temperature data into this variable. Wi-Fi and sleep part allows the temp data connected to URL and send it to the Google spreadsheet. And sleep 5 seconds and sleep 1 second. So every 6 seconds, we can send the temperature data with an endless loop. When we switch on, Wi-Fi module light is on. It is blue light. It is a Wi-Fi, so it takes time to communicate. But you can see the values in the graph. So temperature data is entered. It's around 26 degrees C. I try to warm the temperature sensor with my body temperature. I try to see whether the data increases or then data moves. Since it is winter and my body temperature is low, so it doesn't increase to 30 degrees C, but you can see that the temperature increment is obtained by sending a new data. The similar code written in C language is this: ABC, UART, and clock. There are a lot of initial setting needed. Our board uses microcomputer with PIC32, and in PIC32, sleep and delay functions are not present, so sleep function should be created from scratches. So it takes more than 100 lines to write the program.
はい。続いて MRuby/C ではマルチタスク
Now, MRuby/C has some other tasks, so we would like to show this. I created the project and we tested. And win.rd, and the program is to be written here. First, microcomputer pin should be initially set. This is the pin mode. Pin number 0 is for output. It is designated. While true and end loop should be created, digital write pin 0 is on, so on is 1 in numeral. The 1 second sleep, then digital write, and pin 0 off. And while true is an endless loop, and every 1 second on off is switched. The pin 0 it lights the pin 1 in blue. I write this in and LED starts to flicker. We try to do multitasks, so sub.rd should be created like in the main task. The program should be created. Previously we used the pin 0. Here we use pin 1. Sleep interval is set at 0.5 second. So pin 1 should be on and off every 0.5 second. The main pin stays the same, 0, 1, and it is switched in 1 second interval. And we see the performance. Like this. Pin number 0 shows the similar behavior. And in addition to this, in the sub-file, at 0.5 second interval, pin 1 functions. So we can run the program like this. So in C language, multitask is difficult to perform, but MRuby/C allows an easy development of the multitasks. How do you like the demonstration? This board is available at Switch Science for 3,600 yen, and C source code is disclosed. And also EasyEDA has published the data. So will you please check this? And if you have any questions, please send the message to the Twitter. And our board hands-on workshop is planned, and we are going to notice the hands-on workshops on this Twitter. So please check our Twitters. That's the end of our presentation.